All right, welcome back. We're gonna pick up where we left off in the last tutorial. On my website here, this is where we left off on this testing. And then if you go to phase 4 here, this is where we're gonna start. So we're basically gonna go through the core system of them, like the FastAPI backend, which is gonna be authentication and authorization, and some WebSocket infrastructure and connection management for those WebSockets. So I'm gonna copy and paste these imports here, and then raw passwords should never be stored in a database, so instead we use hashing, which is a one-way mathematical transformation that converts a password into a unique irreversible string. And for one of the libraries that we can use in Python is bcrypt. It's actually an algorithm itself, which includes built-in salt, which is essentially it's random data to prevent pre-computed attacks. So what a salt is essentially is it's additional text data that's added to the input of the bcrypt algorithm here specifically. And what that's going to do is so if I encrypt some data using a salt that I came up with, and you encrypt some data that and separately you encrypt some data with a salt that you came up with, the hashed information that even though we use the same algorithm, bcrypt, the hashed information that's going to be output from that algorithm is going to be different because we use different salts. So essentially, what we're going to do is, like, when a user registers, we're going to store the hashed version of their password. So when they log in, we hash their input that they gave us through the form. We hash that again, and we compare the results. And hashing is one way. So even if someone accesses the database, they can't recover the original passwords because all the passwords that are stored in the database are hashed, and they don't have the passwords to use as inputs to unhash them. So to start, we are going to do password context. Yeah, so we're going to do crypt context with schema as bcrypt, which is that algorithm, and deprecated is auto. So what this deprecated auto does is it essentially like marks older schemes as deprecated. So like if bcrypt were to change in the future or whatever, this allows without us having to go back and change anything. This allows crypt context to go back and like mark the hash as needing to be updated, and then it will automatically do that for us. So then we're going to verify the password. So we're going to define verify password. We're going to get the plain text as a string, the hash password also as a string, and we'll return a Boolean. And then so the return is actually going to use the password context.verify method. And all you need to do is give the plain password and the hash password, and it's going to compare those two passwords and return whether it's true or false. And then we're going to define get password hash. Yep. And that's going to be a string as a password, and then it's going to return a string, which is just going to be what we actually put as in the database as a hash password. So we're going to return the password context.hash with the password as an input. And then I actually had to change some things in the requirements.txt. So make sure if you installed this from the previous tutorial, make sure you have Pydantic settings here. Change the Passlib bcrypt version install to 3.2.2. If we just wanted to test this real quick, we can print this hash here, and then we'll also print we'll do the input. So we're going to do verify password with the inputs of test password, and then the hash is going to be the output of the get password hash, and we'll just go ahead and print that now. And we can do from the base or from the root folder, we'll run this as a module, so python-m app.auth. And you can see that this is our hash password, and then this is the comparison that we just did to make sure that the hash password actually would match. Obviously it will, but the hash password that we create will match the hash that gets pulled out with this get password hash. So moving on, we're going to go over like the authorization part of the application here, which is we're going to use JSON Web Tokens for that. In JSON Web Tokens, it's just a compact URL safe token used to represent claims between two parties. So typically it's a server and a client, and it's made up of 3 parts. You have a header, you have a payload, and you have a signature. And because the token is self-contained and signed, the server doesn't need to store the session data. It can trust the token as long as it can validate the signature. And in FastAPI, we encode the user identity and an expiration time into the token and send it to the client, and the client includes this in their authorization header when it's communicating with the server. So we'll do that. We'll create the access token. So we'll do def create access token. And what's going to be, so we're going to do, not going to use any of this essentially. So we'll do subject is going to be a union of string any, and then the expires delta is going to be of time delta, and it will be initialized as none, and it's going to return a string. So we'll do, so if the expired delta is true, and this is going to be like when we also for when you refresh the JSON web token. So if the expired delta is true, then we are going to create a new expire, and we're going to basically add that expired delta to the current time. Otherwise, we are going to expire, we're going to use the current time, and then get our, out of our .env, we're going to get our access token expires minutes, and that's going to be what our time delta is. And then we need to encode, and our expiration is going to be our expire, and our sub is going to be the subject essentially here. And we're going to encode that to a JSON web token. So we're going to get encoded JWT equal to, so that's going to be JSON web token encode to encode, and then we're going to use our setting secret key. And this is essentially creating the actual JSON web token itself. So we're going to use our setting secret key, and then the algorithm that we're going to use is going to be from the settings as well. So if we go look at the settings, where is that? Here, oops. Our encryption algorithm is HS265. So we are going to use that because it's already set in our environment variables. That's going to be JWT encode, setting secret key, yep. And then we're going to return that JSON web token. So now we need to create a function to verify that JSON web token. So we'll do define verify token. And then we're going to take the token as a string and the database as a session type, and we'll return basically an optional type. Let's go with this for now. So we're going to be DB session, and then we're going to return optional any. And then we're going to try and accept this, and then we'll call this a payload. It's going to be equal to the JSON web token encode. And then let's just go over this line by line here. So JSON web token encode, we're going to take the token and then the settings secret key with the algorithm, which is also in our environment variables here. And then we're going to user ID is going to be a type string, and that is going to be equal to payload.get sub, exactly. And if the user ID is none, we're actually going to return an HTTP code, which will be unauthorized, and then we'll give it the detail of invalid token. And then we're going to finish this try accept here with the JSON web token error. Then I know this looks kind of redundant, but this is specifically covering if this user ID is none, and then just in case for whatever other reason something fails, we're essentially just going to return the same thing. It'll be returned as the same kind of error to the user, but we're going to go ahead and just cover it with cover our errors on the server side with try accept. At this point, we're going to utilize dependency injection, which is it's a design pattern that allows FastAPI to automatically provide required components to a function. So instead of passing things like database sessions or security credentials into every route, we'll declare them as parameters with the depends function. And then FastAPI sees the dependency and then runs this associated function and injects results into our router handler. And it's just a little bit cleaner. For one, it's a little bit cleaner to write, and it's a little bit cleaner to read. Which is one of the things that we try to do as Pythonistas. And let's get rid of this, and then we're going to create our own credentials exception here. So we'll do credentials exception is going to be equal to HTTP exception. And that's going to need a status code, a detail, and headers. So this is going to be, we're going to return 401 unauthorized. So the detail is going to be could not validate credentials. And then this is correct too. So the headers that we're going to send as the HTTP headers is going to be www authenticate, and then the value is going to be bearer. And then So we'll pass credentials.credentials in our DB here into verify token and set that to user. And then essentially what this is going to kind of look like is this is something that the client is going to send, but that might look something like this as JSON. So at least this part of the headers. So it'll be scheme bearer, and then the credentials will be the hashed password here. And then, so if the user is none, then we'll raise this exception, and then we'll also return, we're going to return the user from the database. And then the next thing we need to do is essentially get the current active user. So we'll do define get current active user, and that's going to take the current user, and then we'll just type that as any, and then we'll be equal to, we'll give it a default value of depends, which is that dependency injection we talked about, and then it'll be get current user. Return any, and like I said, we might go back and type this stuff a little bit more appropriately later. And then essentially, we don't really actually need to do this because we handled this in the actual routes. But we're just going to return that current user. If we go to our routes, I have another implementation list version of what we're doing here with our imports pre-filled. And we'll kind of go through these one by one, hopefully pretty quick, and then we'll be able to test everything. We'll be able to test the backend at least, and then next tutorial we'll do the JavaScript and the CSS and the HTML for the front-end client files. So at this endpoint, this is the register endpoint. So anybody who's registering a new user is going to hit this, and then we're going to need to check if that user exists, and then tell them that the username already exists. Obviously, you've seen that in other applications. Pretty much every application that you register for does this. So we're going to get the DB user, and if it exists, then we are going to need to raise an HTTP exception and let them know that that username has already been registered. We're going to need to get the hash password from their register form and create a new user with that hashed password, and then we're going to return the user. So then in order to log them in, we are going to need to get the username from the database. And then if the user doesn't exist, or we go to verify their password using against the password hash using the password that they provided, we're going to need to raise an HTTP exception. So obviously that means that they provided an incorrect password. So here's our raise for that. And then if the user does actually log in, then we're going to need to create an access token, and we're going to need to return that to the user with the token type being bearer. And then to authenticate ourselves, all we're going to need to do is just return current user. And to get the paginated list of online users, all we need to do is get that from the database and then return it. And of course, there's a few things I forgot. In this routes.py, we forgot to, in the auth.py, we forgot to return the user here and verify token, so make sure we add that. And then I think I talked about this in the last video, but this had some unneeded parameters here. So if you have that, make sure you get rid of that, and then that should be fine. And then on my website, I'll have this test code essentially. So because we're going to do this in the next video. But this essentially just sets up like the very most basic implementation of a server, so that way we can check all the things that we just did, save for the WebSocket communication, which we'll do in the next video. So if we go ahead and run this file with that test implementation I just showed you, which will be on my website, and then we go to the docs endpoint here, we can go ahead and register a user, and then this is all pre-populated, so we'll try it out and hit execute, and we'll see that we get a 200 response. If you look down here, these are all the responses you can get, and this is the response that you got, and we'll see that reflected in the server here. We can copy the username, and the password's pass123, and close that, and then we'll actually log in and try it out. So do that, and then pass123. We'll execute that, and you'll see we will actually get to this JSON web token returned here, which we will copy, and then we will authorize up here and close. And then we can, now that we're authorized, pseudo authorized in the app here, we can try these protected endpoints. So if we try this auth me endpoint that we wrote, we can try this out and execute, and you will see again that we get a 200, and we'll see that in the server, and this is what the response looks like. And we can also get all of the users that are online, which will just be the one that we just logged in. To execute that, you can see that we have a list of users, and the user that is online is John Doe that we just created at this time. Yeah, and obviously there's also some schemas here, and I don't think we added any. Oh, I guess we did. This is new. And then I don't know if this might not have been here last time too, but yeah, thanks for sticking around. I'm sorry this was kind of like an information dense video, but we're about 2/3 of the way there, and then the next video is going to be mostly just the front end client files, so HTML, CSS, and JS, and then we'll do the actual full implementation of this file. That's just, like I said, this is just test code here. So we'll do actually like the full, like, quote unquote production version of our main entry point file. So yeah, stick around and subscribe and like and all that kind of fun stuff. And thank you very much for watching and sticking around.